Oh, good morning, team. Yes, this is me again, Michael Jackson Chola. Yes, I think it has been long indeed, since we last communicated. As usual, for those who are new or those who will join later get to know who I am. I'm a registered engineer with the Engineers Registration Board of Uganda, and also a member of the Uganda Institution of Professional Engineers. I'm a member of Project Management Institute, USA. That is a project management practitioner. That is a project management professional from USA. Member of International Road Association, that is Bridge Technical Committee. I think 2024 to 2027. Normally they do after every 3 years. So currently we are active members. That is briefly about myself. Formerly I was with genre as bridges and structure specialist. Now have a temporary contract with Ministry of Works as assistant manager, bridges and structures. And also we have done the interview and we have a letter of notification to join the ministry. I will update colleagues later when we get the appointment from the permanent secretary. I think it might be in the coming month. In the background, you see this artistic impression is for the new Nile Bridge in Jinja, which was completed in 2018, commissioned by the President of the Republic of Uganda. Of course, I've given you the timeline here, 2008 to 2018. 2008 is when the pre-feasibility commenced from Ministry of Works. Then later, 2009, I think that's when now the details of feasibility and other design processes picked up and moved on until we saw the birth of the bridge in 2018. Today I'm not going to talk too much in terms of design, but I'm just trying to share a bit of experience with mostly the graduate engineers, those who are like new in the industry, like you are done with your campus, college, or any other training, and you get a job, and then your boss says, please, we have a bridge. Can you give us the design of this bridge? It's located maybe somewhere, maybe let's say in West Nile or in Kisoro, somewhere south, or in Kasese or in Bondobujo or Mbale. You have never done the design of a bridge, and here your boss is now telling you we need it, and he's going to say, okay, please go have a look at it and then bring me your work plan, or tell me what other information you need so that you deliver the assignment. And as a boss, he will say, my role will be to support you. You are the engineer. I will support you. All you do is make sure you deliver good quality product. So where do you start from as an engineer? I've had 2 cases where young engineers ran and said, yes, my boss told me to do the design, and then can you take me through how to design a bridge using Midas? And then when I try to find out, then you discover that is the first time that engineer is going to do the design. So you have to guide. You say, yes, I have the Midas, but first I need to take you through what you need to know before the final product is out. So basically that is what we are trying to look at. So basically it is a roadmap for construction of a new bridge. And normally most bosses or your seniors always in a reluctant mood, they always tell you we are planning to construct a bridge, but in real sense it's now talking about the final stages. But you as the person, the technical person, you must start from is looking at the last product. For you, you have to now in your roadmap you need to start. Where do you start from? So that is basically that. So as a young engineer, you have to be aware, and then you do that. So this is slightly more about myself. I have a diploma in building and civil engineering, Bachelor of Science in Civil Engineering, and also Master of Science in Bridge Engineering. Yeah, basically that is that in the professional field. I've done a lot of continuous professional development, whereby I got exposed to design and construction and maintenance of long-span bridges, basically more with the Japanese consultant, that is Oriental Consultant Global, and also I did a bit of also training with Kunwa. He's from South Korea, but that was how to design of long span bridges, the balance cantilever, the arch bridges, the post tension bridges using Midas civil. So those are some of the renowned consultants globally that we interacted. Of course, we also interacted with many, Mott MacDonald, and then we have also Arup is there, and others, Nippon Koei, and locally here we have Pro, we have Kaka and partners, we have CAT, we have ICS. So we normally interact, and with that interaction, you continually build your professional journey, and so it's very important. And as a young engineer, please, normally it's important that at every encounter you try to get one or two things that you note down, that will be part of your experience, because engineering is basically experience, and experience is exposure. So it is very important that you master the game and get to know. And because now these days the trend is everything is moving too much. Every new season you have something new happening, and so you need to keep afloat and follow and get to know what it is. Here we had gone to inspect the Kabalega International Airport. I've been following Boy Road's construction since 2017. So every time there's anything to do with inspection, my boss always sent me to represent him. So I think here that's why you can see this is more of this overall is from these guys of Ugandan National Oil Company, UNOC. Yeah, they're in charge of this industrial park and other things. Yeah, so we back to the professional certificate. We have a bridge inspection and maintenance. Yeah, this is, I think we shall get time and talk about that in detail. I will make a present. I already did something. If you go and look at the YouTube, you will see something already done. But still, that one is it is actually very important. You're going to know why someone should be aware of inspection and why you should be aware of maintenance. We did that. We also did asset management with emphasis on bridges and culverts. Risk and stakeholder management, these are all certificates that we have. Negotiations on win-win. So yeah, you always see me on Midas, but actually, if you come and we do more of engagement, you'll find that I do a lot of project management, a lot, and I'm a practical guy there. I've been following projects very well, very closely, but I always see that weak link here, and then the interest for young people. That's why I try to also show them please software, because sometimes some of this other project management aspect is derived from a bit of how you do your design, and then also the projecting, because design will always give you an understanding of implementation and operation and maintenance. So as a designer, you get to know, as a young engineer getting into this industry, these three aspects of the project life cycle are intertwined. So it is very important. So risk and stakeholder management, actually project management, this is a very, very important. Risk and stakeholder management is key. If you cannot manage risk and you cannot manage stakeholder, you can't manage a project. So that's the one thing you need to know. And negotiations also very important. Negotiation always cut across, right up from the site supervisor, the project manager, the MD, and up to a certain point up. You need to know that everything, if there's any disagreement, there's any conflict, you have to negotiate to make sure you keep abreast and you continue moving. So I have a certificate in the new regulation of public, so basically procurement, in line with our local laws, PPTA. Also a bit of FIDIC, because most of this project, the yellow book, we do, and we use FIDIC. So we also have some knowledge of FIDIC, and we also gotten some certificate here. So that is briefly about present who I am, what I am, academic, this qualifications, then qualification, very important. Okay, so from here now I can go. You are a young engineer. Your boss says, okay, fine. Can we? Oh, sorry, I think let me take this back. Okay, let me take stop. It is stop paper. Okay, sorry for that. Technology. I tapped something and then the thing went into the bigger screen. I wanted the square one, so that is slightly bigger, but let me maintain it at that. So you are a young engineer. The boss says we want this, even a box culvert or anything that require build design. So say okay, fine. So normally what we need to do is you need to be first is you think through and begin. First of all, you need to know where is the bridge located. I've already told you. Sometimes they tell you where the bridge is, so you need to know the bridge detail. Sometimes the bridge details in this one is basically you need to know the location of the bridge. Location will help you to say, okay, like now if you say Kabon in Karamoja, you've been a student, you've been hearing about Karamoja, you've never gone to Karamoja. So that means now even the choice of a driver, people who understand the project side, they are the one now to guide you, because you've never gone to that region, you don't know the location. So location is very important so that you can tune your mind. You tune your mindset, the attitude, you organize yourself. Now this is the region, I'm going to go here. You can even research about it a bit. And then always the good thing is you always have we always have someone, especially most of these drivers that take you the fleet assistant, they normally have the area. Like now, if you are working for government, like we said, like Ministry of Works, the Ministry of Work has about almost all regions have the district engineers. You also have the station engineers or station managers. So normally those are the areas you report to, and then you find they already have prior knowledge of the location. Some of these bridges are initiated by area people, like area local leaders, or even can be a presidential pledge or and the rest. So even if it's a presidential pledge, but normally someone, a local person, initiate will say, "Yes, sir, we can't go here. We have problem with education. We are going a long distance, and so we need there's a crossing here." So that's how the whole thing starts. So the local environment is very important. So you will get to know about that, because normally this location will help you to understand local environment. Like for a designer, a bridge located in Kisoro, Kabale, Kitgum will all experience different environmental loading, especially temperature difference. You're going to have it differently. You can see here the temperature, the wind, rainfall, earthquake, settlement. Of course, even settlement will vary, because there are differences in the soil pattern and the soil type. So the rainfall also will be different. Like in the northern Uganda, you have only one season of rain. Therefore, normally when it rains one season, could be having those flash floods which comes and go. Then during half of the period or the year, you may find the river is running very low. So your structure that are in contact with water could be having very little kind of low actions from debris and water. The culture is very important in other activities. If you look at the Nile, this Nile here, or the Nile bridge here, the one I've shown you up here, this shape, by the time they involve a bridge architect, normally these bridges you see do have architects. There were a lot of combinations here. They had to look at the culture of people in the central, the activity, the traditional kind of the ease of calabash, the colors. Many things were taken into consideration. So this figure you see, it had a round. So they put in a lady from Ginger, and that lady was carrying a calabash. No, it was carrying a calabash. Pot, a small pot, like from the well, from water. You see when, and then she was coming back home. So then they look at that, then they say, okay, fine. Then they were looking at people, and then if you look at the Japanese and you look at the Western world people and the African, especially in Uganda, our body configuration varies differently. So during the presentation, they made a joke, and they said that the Ugandan have episode ladies have figure 8. So they drew in a figure 8, which figure 8 actually one day I will try to sketch it. So that there's round here, the head is, the pot is here, which is moving the head, then this part like the neck coming down here and then shaping it down, and then you have the pies going down. It was like a joke, and they laughed because there were different configurations, but that was it. So the architects had to come out. So this inverted Y type, it's not just a matter of a dream from the engineer. There was a thought process, and that was more into the combining culture and the people around and the rest of it. So it is very important in terms of the bridge details and the rest of it. So this is the location you need to know. I'll pick this one just as a sample. Always, even now when you are reporting on your visit site and you always have to know where it is. This is the Nalabale Dam. This was the new bridge. It is here located at this point. And then why are you interested in knowing the bridge location? As a young engineer, these are the areas. Bridges are site specific. That is why you do geotechnical. That's why we do hydrological study. You find that this is the proximity to the source of Nile has a different aspect. If you go down to Kira, and if you go down to Bujagali, and you go further down to Isimba, you are going to have different pattern. And it is very surprising that as you go downstream, by the time you reach Karuma, you still have rock, but beyond Karuma, as you go to Para, now it is silted, so you can see the pattern. That means that if you did this design here and you're going to put a similar bridge of this nature downstream in Para, during construction, we never encountered rock. We went up to 50 meters down with the drilling. Piles are up to 45. Definitely, that means a bridge located in this area will not be, especially the superstructure, which is now what you see above. What you see above the ground, the superstructure system here, can be typical. You have no problem. But as you are going down for the interaction now, the soil structure interaction, the soil type matters, soil stratification matters. So that's why it is important you understand that. You can, as a young, you always go, even when you pay a visit, you have to make sure you study around and see how things are, the environment around, the people around, activities around. You may find there are cattle keepers, that is a cattle corridor. So that will help you also when you are planning the deck sections and the bridge detail and the rest of it. You get to understand. Even the way people manage solid waste management, if the thing is near, like some bridges we're building in Arua, Enyao is in the middle of the city, and then you find Nyachara also in maybe was in the middle, and so some of the things now you have to consider activities around and the rest. That's why it's important to understand. So it's very important. The location is very important. The local environment, culture, this is important. So as a young engineer, you begin, and most of the things when you are doing your, if you attended, or if your university is teaching bridges, normally some of these factors which we are supposed to take care of during design are all captured. So it's very important, because even the bridge construction alone affects normal life of the citizen or settlers in the area. So the issue of social aspect need to be taken, environmental and social aspect need to be taken into account, whereby sociologists have to come, talk to people, let them see. That's where now the issue of stakeholder management has become very important. So this is just a typical location. You can have so many. You can have your cross so many bridges. You can actually look at it. Now the next thing, once because when they tell you to design the bridge, then say, okay, fine. Then where is it located? Then you begin to internalize. You begin to understand certain things. Even when you go to site, these are some of the things you start picking. But now, a bridge is not designed by one person. But your boss is saying, please, we need this bridge. In the next 3 weeks or next month, I will present it to top management that I want the bridges to be ready. So you say, okay, sir, that's okay. So you say, okay, fine. You come back, go back to your room, jot down all these points. The team leader, you might be now the team leader, because you are now being a task. So you are the most responsible person now here. So you look at, as a team lead, the experienced bridge engineer. If you're not, you can actually also suggest that you get, but for you can now do the coordination role. You could be the expert in the bridge designer. So you become the structural engineer, and then you give respect to someone hired and you do the team lead to guide. So you need to have an experienced bridge engineer. Then you need to also have knowledge of the structural engineer. Now that is you, because this one can also guide you. So now then you come. Then you need the geotechnical. I told you the soil type, location. Soil type is very important. If you get rock, how do you handle rock? So the experts in soil mechanics and foundation should be part of your team. You also need hydrologists, because the bridge openings are determined by hydrologists. So it is very important that you get this on your team. You have environmental specialists, expertise in that, the sociologists, maintenance specialists, even a construction manager you can still put in, because as you are doing design, even quantity surveyor. There are many I have not put for you. Yeah, so you can also do quantity surveyor, because they have to now do what they call get to know where materials can be sourced from, the type, quantities, and other things. So it is important that most of these guys who prepare the documents understand the quantity survey, and then others etc. So then construction manager, and at least now you know I've given you the minimum. Okay. So because this team composition, even surveyor, the surveyor also have to be here. Quantity surveyor and land surveyor or surveyor, because they are the one to determine the topology. They need to understand the terrain behavior, because your house, the site is the topographical survey. They need to do it, set benchmark, temporary benchmark for construction, for design. Even the one of actually highway engineer also should be part of this. So instead I put for you highway engineer, then I can leave it, the rest you can think through highway engineer, because it's the one that comes up with the, because a bridge is actually is part of a road link. So you derive that from how the road behaves. If it is in a curve, your bridge also will be in a curve. If it is in a in the slope, the bridge also will be in the slope. So it is very important. So this all derived from the highway engineer will do for you the design, and then you fix in the bridge. So the team composition is very, very important. You don't know the team you're going to work with, you will get into problem. You just start running away from your bosses. You'll not even do work. Now, once the team, you have gotten the team, then you get to know the design data, the data you need, because you need to have the data. The data, very important. Of course, the bridge location, I've given a name here. I've got put Kisoro. The bridge type, that one normally is done. You can actually do from the literature, and then you get to understand the bridge type, whether it is steel, whether it is concrete, or can be out of steel. You can do steel truss, steel composite, or if it is concrete, you can have reinforced concrete, slab concrete, and then you can have post tensions or pre-stressed or reinforced concrete. So, and then the span length normally is determined from hydrologies, and then from hydrologists, it does this calculation of the catchment area, determine the discharge. Some of you have done water resources, at least you have some basic knowledge here. Then quite a number, though I've not mentioned, but at least now with this discussion you should be able to. So you have to have soil properties. Then you have to have like a discharge, and then you have to have what other things, etc. You will learn now. So the load capacity here, we don't need much, though you need to know the expected traffic and load requirement. That is very important. Expected traffic and load requirement. So the use of, you're going to see the references. There are some of the things you can get them from the reference they are using for design. But as a young graduate, at least you know they have said design for as a bridge. So what rings into your mind is, where is that bridge? Who am I going to work with? Do I have ideologies? If I have the in-house team with all these credentials, then you put down all this, you prepare your work plan, and you start with all that. These are the team. You can actually ask for a formal appointment now from your boss, a formal internal memo, so that you are able to to now get the people, get them on board. The first thing is introduce the topic. You ask for facilitation, get the drivers who know the place, arrange. If the team are more than 6, 7, maybe 2 cars or 3, you visit the site, get to know people. When you reach there, make sure the local council people, the local area leadership are aware. You ask your representation in the district, they are aware. All of you meet, have a discussion, look at the site. That is the first to familiarize, and then you have the initial meeting. Then later on, the different expert can go back. So once you have now known the site, now you can then start. Even people, hydrology people go back. Then the geotechnical can mobilize a lab, and then if the lab is decentralized, you have them in the district. This will be able to do for you the work. So you know, design data, there are quite a lot. So I want you to think through. I was excited and I put for you here. This is a Para Bridge 2018-2023. Yeah, this was constructed under the under oil roads, constructed by CCC, and CCC contracted Tikoi from Denmark as their designer with the contractor, but the supervisor was from Consult, locally based. So it's a 520-meter bridge. You can see the pier support system is pier column system, and this is where I'm telling you that then knowing the site is very important. The geotechnical report here revealed no rock encountered, so they had to go all the way down. The geotechnical expert advice, and then that's how they handle. So basically, this is it. So the location matter. Now, when you look at the Nile, this bridge, which was here, this area, the rock, this island you see is a rock. The rock outcrop here was too much. Within it was deep and strong. With UCS values going more than even 100, you get it. But as you go down, even when we were dealing with Isimba, you're going to see a Simba down. We were drilling through rock, serious rock. But as you go downstream, Karuma also has rock. The existing Karuma bridge has rock. Even the new one we are going to work on even has rock. And so, you know, the terrain, the whole geography, people who have done geography, it's a bit the same Uganda, but as you tilt away, it's a different soil pattern, it's a different stratification, environment is different, everything. So that is what you need to know about this. It's actually is in Maction Falls. Yeah. So that is that. After the design data and team composition, what need to ring into your mind as a young engineer is, what does it take to design a bridge? What is the process? What is the process? These team members up will go and collect data. Yes, they will collect for you data. After collecting data, so what? Now this is now where a bit of project management comes in, a bit of coordination comes in. How do you plan the thing? Who is the first on board? Who is the second? Or which activity should get completed before the other one? Or which activity can run parallel? You look at these things, so you find actually, okay, site investigations and data collection. Then you on a site investigation now. Site investigation is actually wide. All this, sometimes they may tell you on a site investigation. Then sometimes we rush and say, okay, this is boring. That is drilling. Survey is also site investigation. Environmental study is also site investigation. You are investigating to get more data about that site so that you are able to fix the bridge, design it, and construct it. So basically, so hydrological analysis and hydraulics. Hydraulics is always an output. No, it is an it results from hydrology. First, understand the discharge, the flow in, then the flow behavior. Now matters with the type, the shape of the river, the type of soil you have, Then the scoring, they have to calculate the score debris. So the hydraulic part of it now does for you all that when hydrology. Then there is structural analysis and design. This is now where now you, as the person who is in charge or delegate or tasked by the boss, you are now maybe the structural engineer. That's why they ask you first from campus design for as a bridge. Now, for you to get all this information, that is now you are now getting exposed, and even experience is getting built up now. And by the next time you're going to go back to your boss, you're going to put him down, and you can actually make a presentation on PowerPoint, and people will listen to you. They will nod their heads, and they will say, yes, this young man or the young lady is going to deliver. And they will become relaxed, and they can actually be flexible, and they can say, okay, when do you think you can deliver? At first, they had given you only maybe 3 weeks, but now when they realize that you understand the flow chart is very important, the flow process, you know it, then they will now say, okay, fine. And all this you can tag the timelines required. Like now, site investigation, maybe minimum is two months. Geotechnical investigation, okay, site investigation and data collection is general. This one, I think I would have done that. Because geotechnical investigation and soil analysis already here, maybe could be 2 months. Hydrology could be also another 2 months. Geotech, if it is a bit stubborn water, like for this one, can even be 5 months. Because setting up, yesterday we were in Pakwach, the other day, yesterday but one, we were in Pakwach Bridge. And CCC is trying to do geotechnical investigation upstream of the existing bridge. So what they have to do, because this is River Nile and it is very deep and also it's a bit stubborn, it flows with the floating vegetation, they first have to prepare a jetty. You design your jetty and a platform. That platform is where you go to mount the drilling rig, and so you walk, and then you take that drilling rig, you set it up, and then so that process alone can take a month or 2 before you start the actual drilling. Now that process helps you to understand, even to gauge the schedule or the timeline, and that will determine also to guide you as a young engineer that the initiation or the commencement of implementation may not be in the next 6 months or 3 months, because the 6 months alone could be the time for data collection. What are you going to do? But because now you have a task, you start getting all this information. You start getting the stamina, and said, yes, I'm an engineer here, and you talk with authority. This is where people derive authority, knowledge of some other things. Environmental impact assessment is very important. Our construction processes destroys the environment, and therefore it has to be regulated, and that is why environmental guys come on board. I think in West South Africa, I think some 1 or 2 projects I think have been made where the project manager is not a civil engineer, it is the environmentalist, because your component is going to be put in an environment. So the environmental officer or expert understand how you should do it and will control your process. Very soon, most managers will be the one, because if I cut a road, my road is going through a forest. We did the Masini Kisanja up to Tangekro Para Bridge. We were controlled by NEMA. We were guided very well through the forest. We were not supposed to create a bigger opening, because this forest on either side of the road must interact to allow communication of the different monkey families and baboons and the rest to communicate, but from up the tree. So you find when you are driving through, you find the road is narrow and the trees have started rust. Actually, I have a picture. I think if I could get it here, I can share with you, and you see the trees. So I'm going to search for it. The trees get touched together, and then these monkeys jump, because from down they can get knocked by speeding cars. Although there are speed control, of course we have speed control. Let me not mislead the public. We have speed control 40 kilometers per hour. So we need to abide by that, so we don't kill an animal that attracting tourists. Then inspection and maintenance. Why do you put the inspection and maintenance planning knowledge at the design process stage? This is now where I'm telling you that if you look at this bridge up here, the bridge is good, but when you say inspection, how do you get down here? We don't have any access for inspecting this pier cap if there are problems with bearing. So the only option here would be now to have a knowledge of. So part of the project cost could be the equipment, inspection equipment like a vehicle. You're going to see, I think, 1 or 2 down. So that knowledge helps you. Sometimes you design. So you find that when you are putting the guardrail, you have a slot for access on either side. So you are designing, as you're modeling the project, you are configuring the bridge. It takes care of inspection, access for inspection, even access for maintenance. So these key areas like bearing areas, somewhere down, it is very important that you, even expansion joint, it is very important how. And if you are to replace expansion joint, you get to know, maybe instead of having a smaller bridge width, maybe during a replacement, maybe I need to avoid rerouting tracks. Example of Vokaruma Bridge, we have had a bit of inconveniences to the public where you close the bridge and then they go very long distance and they get a lot of problems because you're only fixing a 8-meter expansion joint. But if it was done now in the design, you say, okay, this 8-meter, break it into 2. So you'll do 4 meters while the vehicle is using one side. Then you do so in your design. You take care of that, so that even during replacement, it's supposed to be replacing piecemeal kind of, but in a more planned schedule. So inspection and maintenance planning must be part of your design. Even constructability is very important. Constructability, very important. You need to have knowledge on construction process and equipment to use. Now, if like now piling, you can't just choose. Piles have, I think, 600, maybe 900, maybe 1.2. So sometimes the contractors who are coming on board have already the equipment with, like for the drilling rig could have a diameter of 1.2. Therefore, they will tell you, if you design for 1.5, that one now we cannot. So to mobilize a new equipment is costly. So you always look at the constructability of the available equipment in the market that guides. So that knowledge is very important. So as a young person, don't just bury your head and start modeling and say, I'm done. The bridge cannot be implemented. Even the kind of grade of concrete you specify, where to get material from. So of course this one I picked, this is more general, this is generic kind of, where they talk of identify the problem, do a bit of researching. This is the engineering design process. Research a bit, develop possible solutions, select best solution. This is now where I do your feasibility, what. And then of course for a bridge, at least you get like 2-3. You can look, I talked about it up there. You can do a steel, you can do concrete. Out of steel you can do steel truss, you can do steel composite, and then for the concrete you can do reinforced concrete or pre-stressed concrete. Under pre-stressed concrete you can do post-tension or pre-tension. So you look at all that, you weigh, see availability of material, availability of technology, procurement process, everything you look at. And then these days they're talking about the carbon footprint coming in, climate change adaptability issues are coming in. Then what they call how do you handle retrofitting in future? How do you plan for it? You need to understand the use of redundancy. So you learned something in your theory of structure, redundant members, that their presence or absence may not, their presence will give the conservativeness to the structure, but their absence may not impact on the functionality. So it can help, the structure can readjust the load path, and in doing so, you are able to retrofit effectively if there's need in future. So those are things that so during that selection process, possible solutions, you do what they call the appraisal. Then you look at all the other factor. Sometimes they call them use of multi-criteria analysis. Then you choose what you think is okay, best part. Then you do that. Select the best. You build it, test it. Then that is done. But of course, you will learn more as a young man. So responsibility process. Now this is now the other team lead, and the rest is now where you define their responsibility here. So the team leader will be overall project management and coordination. Then the software engineer will be the will be the one designing. Then the geotech is already doing his soil analysis and other things, hydrologist, maintenance specialist, quantity surveyor, so many. I mean, not limit you, except so many. Then, having known the above, the design, location of the breed detail, the team composition, data to be collected, responsibility, who does what, because if you don't know, you're going to have two environmentalists, your friends say, let these two guys come, but one is going to be redundant. Then you have to pay and you have to account. It has to be used in another project or another project, so you have to be careful with the choices. Then the design references, always very important. As a young graduate, normally you need to be mindful, because properly, I know in the former UNRWA, our director then, Isaac One, tasked us to come up with design guideline. Actually, the issue of design guidelines started way back in 2014, where consultants come, they do they offer technical assistance, they begin to think, what needs to be done, how do we, so they came up with a bit of overall what need to be, design guidelines to come, and a bit of narrative. But it got intensified, I think, 2020, 2021, 2022, where now I think we had even a retreat in Ginger to look at that. But we realize the design guideline is very important. And I managed to contact some of the seniors from Oriental Consultant, and because we had a lot of questions to those who are offering technical assistance, we kept telling them a guideline is more, it's deeper. It gives you all the processes, what need to be done, but the way we are having it is more summarized. So it can mislead at times, but so we up to now, I know we still need. So what they guided me on, and which I appreciated, I got one from Indian website, and I discovered that actually when you give a design guideline to a student, like new graduate, with a bit of few consultation, the graduate should be able to design the bridge, especially the smaller bridges, because all the processes you need to do, factor of safety, all these other things are all there. So guidelines, I managed to get some, but more of Ashito, this F dot thing, and I think maybe moving forward in future, maybe if the ministry can take on that, we shall see how best, if we can find a way, get consultant and developed with consultation of these established already bodies in the world over, so that we have guidelines. Codes of practices we need to have. These are very important. We have the latest British standard and also Euro codes we have. Then we also need to have the use of national annex, codes and annex. Like now for Uganda we need, because I've told you we have the earthquake. We have the earthquake. Zones. The western axis is zone 1, the eastern is zone 2, and then central is zone 3. mild. Zone 2 slightly basic, you have to take care of, and then 1 is very active. Every year they experience tremors. So now that means our earthquake may be, the magnitude and everything varies from other. So we need temperatures of varies. We need our own national annex that even the axle load, the vehicle we have today, because of oil roads, not oil roads, because of production of the plant production and commercialization of oil, industry, and gas. Now, out of this vehicle or trucks have started plying our routes, and we have been receiving quite a number of requests for permit requests to cross bridges, and we have seen some goes up to about 200 kilonewton, 200 tons, and therefore that means that even the width up to about 4 meters. So now it guides. So we need to have the East African axle load control requirement also need to form part. So use of national annex. Okay, so now this one so help the student to understand some of this. If we don't give them, or you don't give it to the student, definitely the graduate will not be able to perform, because some key information that is you are privy to is not now being accessed by the person who has been tasked to do the design. Publications, manuals, lecture notes. If you have done bridges as a course, you should be having relevant notes and handouts, benefit examples. So as a graduate, don't run away from those. Most of these things are practical, and so you need to follow. That is very important. So design process, design references, responsibility, the issue of process required, the issue of design data, the issue of team compositions, and the bridge details and locations are very important that you need to know. Now, when it comes to detailed design, now you already got all the data. You have engaged people, you have gone to site, they have seen it, have appreciated it, you have all. The hydrology has given the sizes, the surveyor has given you the topographical survey, the highway engineer has given you the profile. You now know your bridge. Is it at a level? Is it at a curve? Is it on is it valley, slope? Now you have all that. Now you are able now to sit down and then begin to plan. But again, I told you, there's a bit of planning you need to do. You may not wait. If they give you only 1 year to deliver, you may not wait until all this data collected. You have to plan some data. You need to start with for by the time of doing feasibility. By the time you start detailed design, you may find actually now it's only left with few things. So you need to know what you need to do before the other one, and then like the geotech, hydrology, survey can all happen at the same time. Even environment, even social. But of course, environment may need to wait because they need to know where exactly the approach roads are passing and the bridge located. Then they can do it. But these are one example. But even by that is important. So the survey and highway become key, because these two, once they do the topo and then the surveyor determine, the highway determine now this is the best location, and then the structural engineer also have confirmed that this seems to be. Well, then the study can be done, because even hydrology may do it as few meter downstream, few meter upstream. The same happens to the surveyor cut section downstream, because you can still do and adjust. So now you begin to think along that. So you're going to find that you may dispatch the whole team to site, or first week they will go collect some data come. Then the team leader, the structural engineer, will begin to sketch few things, and so then you need to do both internal and external engagement. Internally, they will tell you what needs to be done. You get guided. So you need to do a lot of listening. There's a lot of lesson to learn, because you are a graduate. You are new. So there are experienced fellows, guys who have been in other companies, they know what to be done, but they've not been given the responsibility. So you need to listen and do. Ask questions, ask for guidance, accept to be trained. Because if you don't do that, some people need that ownership, that so and so is my boss, is coordinating, but he listens to me. So it is important that we do that. In the detailed design now, you from feasible. Of course, now I think here something will confuse you a bit. What I would have done is to have in the design reference, and then I needed to have done a bit of feasibility before going to. So you need to have a feasibility stage. Where the bridge choice is. So you do appraisal at least three bridges from bridge type. Bridge types to get preferred. From detail design. Very important. So that's some summarize that for you. So so this is exactly what we do. Very important. So this stage is where you do preliminary. You do actually this is where you could even be doing as they are moving with these other activities. You're already doing these other things. So now when you're done and you've collected all the data down, you now know you've chosen the bridge. Now you can do superstructure design. Now you know if it is steel composite or it is a deck and beams, etc. Then you do bridge substructure design. Of course, there's what they call bridge deck load analysis and design. So you must also know what loads you need to apply on the bridge. And then I think that one we are looking at the deck load analysis. But for now, so I've done your feasibility, and you move to detailed design. You do bridge substructure, that's the pier support, abutment, foundation design, pile footing, hydraulic design, waterways. Of course, now hydraulic is also trying to refine. Now, inspection maintenance planning, I told you, this is the knowledge you need to have. We are not doing that inspection, but at least you know. If you're going to use drone, then you say, okay, fine. How do you honor your structure? So now, because today drones are now new technology they're adopting. I think previously we were doing manually. You climb, use the ladder, inspect the bearing. Now you can do drone and can even generate the 3D. Even all these other hidden things you can use drone and do it. Then this is the vehicle thing. Now you can see this is the long arm. This is the vehicle inspection. Inspection vehicle, you guys can take you around, inspect here properly, and then so some of these, of course, you need to make sure they are part of. If you are not doing this and doing the local one here to go on, you have the down ladders here, and then around the bearing area. So identify potential inspection, maintenance need, design, inspection access. So all this knowledge help you to plan for a bridge that in future and have proper access for inspection and proper access for maintenance. Then the design deliverables, you also need to know that as an engineer, what do they want? And they said we want the design of a project. The design of a bridge report, you need to know you have to have detailed design drawings. You have to have, that means you need to know to have on your team, you need to have CAD engineers, AutoCAD, people with AutoCAD knowledge to do a draft. Technicians should be there. Technical specification, inspection, maintenance plan, detailed calculation reports. So all those guys will give you reports. Your technical report, hydrology report, structural report. All those will be your attachment, but also you need to give a narrative report. Yeah, very important. So this is your Simba. The Simba bridge is about 890 with the cover island here. Up here upstream is your the dam. So downstream is where the Simba. This is the one they use for construction of the dam. So the tour to the cover island. So the other side is Kayonga. This side is Kamuli. And all these areas, each of these piles are all bearing on rock. That's the benefit upstream of River Nile. As you go down, I told you to Para, it is now still sand and the rest of it. So that is what you need to do. After you have this report ready, then you do your report writing and finalization. As in the engineer, you look at introduction, background, design methodology, assumptions. Of course, you may not get all the information to do your design, but some areas you make assumption, and these assumptions should be consistent throughout, even up to construction. Sometimes you may find you don't have access to drilling rig, but you can do DCP. Yeah, you can do DCP, but make sure you also advise and put in the report recommendation for detailed additional tests to be done by drilling during the mobilization stage when construction commences, so that the engineer can revise the foundation accordingly. So, but DCP can give you a bit of some, because it can go out to about 5 to 6 meters below riverbed. But in most cases, if you are lucky and the river is on rock, then you normally encounter rock early enough, and you just raise a sword. Just make sure you confirm the rock is continuous, both down and on the side. Then design results and recommendation, inspection maintenance plan, conclusion and next steps. Yeah. Then the report review. Normally it's important to do quality assurance. You have your team leader, you can do the report. Each of these guys can do. You have some internal presentations. Make sure the whole information is captured. The flow, logical flow, the grammar, of course not all of us are good. Now we have AI. Some of these reports now with the grammar can be corrected. AI can give a very good report, but you need to know how to use it. Meta AI has a very good report. Very good report. And you just need to know what to do. You need to know what to do. It's like a talking computer. If you hide information, it will not resolve. It will not give you the output. So you need to. So review is very important. Quality assure everything, and then from there, once it's done, incorporate review comments, finalize design report, prepare and submit final design report. But also it's important to keep your boss abreast every time. So you can say every week you give a snapshot, you give a bit of a brief of where you are, what is the remaining time, achievement made, some maybe there are challenges, so that when it's updating management, they don't call you when they're already in a management meeting. Always you do, and make sure you always save your project in let it be in your official email, personal email, WhatsApp, because anytime they can ask for that information, they should be able to avail. So any communication you do, make sure you copy yourself in all the communication, all the correspondences you do. Make sure you copy yourself, because anytime your boss can easily ask for a report, and immediately. Yesterday, but when I was heading to Pakwach, fortunately I moved with my laptop, so director called, and then former director, he's head network planning engineering, called me and said, Michael, I need a letter which you wrote, Word version you wrote in May 2023. Can you share that? I said, yes, sir. I quickly opened my laptop, we are moving, found the thing, send it to my WhatsApp, forwarded to him, and everything fine. Nothing was saying, let me come back, I've traveled to the field. That one is not now, because sometimes we need to know how to manage stakeholders. So in the construction preparation, now also think along. Even you need to understand, that's what the procurement, normally a lot of queries come from bidders. So as a designer, you need to be aware. You need to be aware of all the report must be logical. Your design drawings must communicate with design narrative. If you talk of concrete grade, must communicate. The general specification, you also need to know what is the category. So you need to know that everything is specified. Normally contractors come and say, your drawing is saying class of concrete is 45. The design report is saying class of concrete is 40, and general spec is saying it is 35. So you need to know. So that's where now they start running. Now what do we do? So it causes a bit of delay and can easily end up with overrun on time and cost. So it's very important. So this tender process, you prepare the tender. This tender documentation now will be, but the rest you have already done. If you have all the design report, that form part of that, the employee's requirement. Then now the procurement department handle now the standard documents and the way procurement should be done. Then the advertisement is done. Evaluation will be normally you as the graduate or the one doing. You might be part of the evaluation team because that's because of your expert knowledge. They always call you. Then there's a write of contract, and then the project goes on. If you are lucky, you continue with the supervision, and so you do that. Then construction planning. Now also you need to know. I told you there's a bit of planning even here. Even the design report sometimes has some planning already done. Like you do inspection and maintenance planning, construction, even the kind of equipment. A designer should be able to anticipate something. Then the contractor can come with what they think works, but at least you. So normally, when you're doing design, you design, construct, and plan and maintain from your computer. Look at it all and understand it. That makes it even better when they're discussing. You're not lost always. So you develop construction schedule and plan, identify and mitigate potential risks. So this risk management, risk register must be developed. So your output, stakeholder engagement plans, risk management plan, all have to be there. Communication plan also have to be part of your report. Very important. Then coordinate with the stakeholders and contractor. These are the construction planning. So you can now see these are the different planning: groundworks, excavation, backfill, structural works, reinforcement, concrete. This is just a kind of to show you that you're also responsible. So normally you're a surveyor. So this one now, the different team you have will be the one to do for you. You have to coordinate. You need to know who can provide what. You can also have that because use of MS project many people can also use. So you need to understand this one. I think they use basics. So you can do MS project, or you can do Word, you can do Excel. Yeah, so basically that is something you need to be aware of, that you can also do this planning and can also form part. Then the contractor can now return, and then they can give theirs with the explanation, because they are the one going to implement the project. Special maintenance plan, finalize inspection plan, blah blah. So of course, here I want you to map. This knowledge is important to guide your construction. But even this planning here is also help you to understand. I'm not saying now we are going into construction. Construction, if you are to talk about it as its own merits and what need to be done. But as a designer, you must be aware that I design, I can follow construction, and I also follow the maintenance. That are they making sense? Are they flowing? Are they communicating? So that is why you need to know. You see, even this timeline, I told you can give timeline in construction. Even that design you are doing, even data collection has timelines. So you must be aware. And when you are in a meeting and you are coordinating, you can ask each of them, I want your detailed work plan with costs and timelines. You get it? So all of them, even risks. So you can now compile the risks, and that's what you always explain. By the way, when you are going to your boss doesn't have time. Make sure you understand the kind of report you give your boss. Normally 1 page or 2 maximum, and hit the point. Project detail, the scope, what you are supposed to deliver, what you are doing, how much you have done, what is remaining, when are you delivering. If you can't deliver, you have to start saying. So the risk affecting delivery must be captured. The stakeholders, some stakeholders might be difficult and therefore may require your boss. It's very important. During oil, there are things that we couldn't honor at our coordination stage. So our former ED, even the minister works, General Katumba, they would go, and the Prime Minister Nabat, the Right Honorable Prime Minister Nabat, they would go for land acquisition issues to talk to people. It is escalated at a higher level. Episode that package 3, that is the Bohemian and Loyal community. So you find you have the different stakeholders with different interests. That's the most critical thing that normally many of us as young engineers fail to do. First project you fail. You become emotional, you become passionate, remain technical. Always remain technical, explain your technical area, the implications, the successes, positivity, so that people understand. Simplify the English. Some of you started from Birmingham, others from where. You tone down, and actually you can even speak broken English so that people understand you. Sometimes you say, guys, the way he's talking is funny. It's not funny. Someone is understanding. You can give broken, you piecemeal information until someone understands you. That is all. That's all matters when you are now a practitioner. So it is very important. So, in conclusion, the roadmap outlines above incorporates inspection and maintenance planning into the design of the bridge, ensuring that the bridge is designed with consideration for long-term maintenance and inspection needs. By following this roadmap, the design team, guided by the team leader, co-coordinator, who is the graduate engineer, assigned by his boss to ensure a bridge is delivered, whether it is in Karamoja, in Kasese, in West Nile, it is done with minimal disruption and then with less delay time, so that the implementation can come. You may find the implementation is stuck to the election coming next year. So it is very important. So basically that is that. And I think you need to, so the design team can ensure that the bridge is designed and constructed to meet the required standards and specification, while also minimizing potential risk and delays. You see now what I'm meaning here? Specifications are here, risks are here, stakeholders are there. So as a graduate, please listen, consult, ask questions where necessary, take a lead in researching many things that are similar, and then always stay afloat. Coordination is about communication, time management, and understanding what the role and data required for the design come from. So with that, I think I say thank you for listening. We shall continue sharing. Thank you so much. Michael Chola Jackson, remain my name. Thank you.